Here we are working through the extension practice sheet, the odds. So if you are just getting ready for the power assignment, this will not be on the power assignment. It is good practice, though, for some of the portfolio work. It's just an interesting thing to know also, whether your series converge or diverge in these infinite sums. So let's give things a look. When it comes to deciding if we converge or diverge, just look at your common ratio. That's all that matters. Common ratio is 4. Absolute value of 4 is bigger than 1. This series diverges. Common ratio here is 1/4. Absolute value of 1/4 is less than 1. This series converges. Look how simple this is. Here, you've got to know the setup. So this is your first term, your common ratio. Absolute value of that common ratio is less than 1. This series converges. Here, common ratio is -1/3. Absolute value of -1/3 is 1/3, which is less than 1. This series converges. And before I go too far, I think I want to highlight some things. There we go. Now for these next ones, you'll notice it doesn't tell you what the common ratio is. You actually have to figure that out yourself. So the easiest way is to say, well, I took 4 times something to get 16/5. So divide both sides by 4. Divide by 4, divide by 4. That's going to then give you your common ratio. So, and actually I should be more careful. It's a -16/5 we ended up at. So do that, you're going to end up with -4/5. So all I did, I took this term here, divided by this term there. If you're more comfortable doing that on a calculator, you certainly can. -16/5, and then divide by 4 gives you that same common ratio of -4/5. Decimal version is okay as well. What we then know, absolute value of this, well, that's less than 1. Therefore, this series converges. And then lastly, same thing. Matter of fact, all you kind of have to do is look at the numbers. 10 times a number became 2. That means that number had to be smaller than 1. So this series is going to converge. I know that because the size, the magnitude of the numbers is getting smaller as you go down. Now let's be a little bit more careful. We'll take a moment, just make sure we can figure out what that common ratio is. So 10 times that common ratio equals 2. Divide by 10. That means your common ratio is 2/10, which is 1/5, which has a decimal is 0.2. The absolute value of that common ratio is less than 1. Therefore, we have that series converge. Now, as we look at these last ones, we're now going to have series that converge at least most of the time. Just check, though, from the start. If your common ratio, which in sigma notation will be the number with the exponent on it, if that's more than 1 in terms of its absolute value, then you don't need to do any more work. It doesn't converge. If, however, as in this case, we do have a case where the common ratio is less than 1 and therefore converges, just set it up this way. The infinite sum is always your first term divided by 1 minus r. So in this case, our first term is the 128. The common ratio is 1/4. So I want to do 1 minus 1/4. And then let's see what we get. I think I'll do this one here. So we started with 128, right? Divided by, now put this in parentheses. Your denominator does need to be in parentheses. 1 minus 1/4. And we should end up with, ooh, that's not a bad number. I just want to turn it into a fraction. So 512/3. And again, to turn it into a fraction, press your math button. It's the very first option there in the list. So coming back, 512/3. There is the sum of your infinite geometric series. And be a little bit impressed. We have a way, in some cases, to be able to add up an infinite amount of numbers and to get an answer out of it. Good work, human beings. Good work. Next up, same thing. The infinite sum will be your first term divided by 1 minus your common ratio. If you want to do some work in your head, that's okay. 1 minus 0.9, well, it's just 0.1. And dividing by 0.1 is the same as multiplying by 10. This sum should end up being negative 20. I do recommend a calculator check, this being the 21st century and all. So negative 2 divided by 1 minus 0.9 equals, look at that. We end up with that negative 20. These next two, well, these are actually even a little bit easier, aren't they? Because you don't have to guess what the first term and common ratio are. They straight up are telling you what the first term and common ratio are. So A1 divided by 1 minus R. This one, just for practice, let's review our fractions. Minus a negative is like plus. 1 plus a third, that's like 3/3 plus 1/3, which is 4/3. 1/3 divided by 4/3 is the same as 1/3 times 3/4. The 3 is reduced. This should come out to be 1/4. Let's check it though on our technology. I'm going to use a Desmos here. On the top, a third. On the bottom, 1 minus negative a third. And look at that. Comes out to 0.25, which we know is 1/4. This is pretty cool. I enjoy the infinite sums just because they're super neat. Super neat. Next up. So A1 is 16, R equals a half. You don't need to do this, but let's not forget what we have. What we're doing here is saying, all right, take 16, add to it half of 16, and then half of that, and 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 never, ever stop. That's the number we're finding. So this infinite sum is first term over 1 minus that common ratio, 1 minus a half. Well, that is a half again. Dividing by a half is the same as multiplying by 2. So this sum will come out to be 32. And then lastly, this time we are given the first several terms of the series, meaning I've got A1, right there it is. What we don't have is the common ratio. We've got to figure that out for ourselves. So A1, what is this R? Well, I know that 6 times the common ratio gives me a negative 3. Divide by the 6. R is negative 3 over 6, which is negative a half. So the infinite sum is the first term divided by 1 minus negative a half. 1 minus negative a half is the same as 1 plus a half, which is 3 halves. 6 divided by 3 halves is the same as 6 times 2/3, and 2/3 of 6 should be 4. Let's double check that then on a calculator machine. So we had 6 over 1 minus negative a half. We end up with a 4, and oh my goodness, it's like it works out super, super good, like it super, super should. Apologies for that. As soon as I said it, I wish I hadn't. Okay, so there it is. When you're dealing with your infinite sums, you converge if that common ratio is less than 1 in terms of its magnitude, and you apply that infinite summation formula to determine the overall sum.